Welcome to another lesson in this AutoCAD video series. In this episode, we are going to cover georeferencing and digitizing. So to be precise, this is the image we are going to georeference and then digitize the content. So this is a layout plan that was prepared long ago in the 90s to be precise, and it was prepared manually using pencil. So a hand designed layout is presented, and all that is available is what you can see on your screen. So it is actually a paper map or paper plan that was scanned into the computer. So we need to georeference it and then digitize the content. So in this very video, the very task we are going to cover is to determine the area or the size of this irrigation farm. As you can see, this is where the irrigation farm covers. So we need to find the size of this area and then split it into 3 equal areas. So after getting the total size, we will now split it into 3 equal areas, something like this. So I hope you got the message. So in the subsequent videos, we will digitize other features like the layout blocks and then make some corrections to the layout, because this was done long ago, so there are some things that need to be amended. And a typical one is like these cross junctions. So the implementation of the layout requires that we shouldn't have these T junctions. So we are going to amend it on the new version of the layout we are going to prepare in the subsequent video. And also, if you take a look at, there are some plots that actually have no access routes. So a typical example are this. They don't have access route. That is, no road on either side of the plot. So we are also going to amend some of these mistakes. So that will be in the future videos. So, but in this very one, let's georeference the raster or the image and then determine the size of this irrigation area and also split it into 3 equal parts or 3 equal sizes. So let's switch to AutoCAD environment. So before then, I will mention that we have been to the location of this project, and then we have collected the coordinates of this point. That is this point 1, point 2, point 3, and then point 4. So if you look at, I don't know if you can see the point labels very well, but these are the points. This 1, this is point 2, this is point 3, and then the 4th point is here. So the coordinates have been collected, and we are going to use those coordinates to georeference the image. So these are the coordinates for point 1, and these are the coordinates for point 2, these are the coordinates for point 3, and then that of point 4. So to georeference this image, all it means is that we need to make this point, that is point 1, to have this coordinate exactly. So this is the easting and this is the northern. Then point 2 will also have the corresponding coordinate, this easting and then this northern coordinate as obtained from the site. Let me switch to AutoCAD. So here I am on a new project environment in AutoCAD, and all I need to do is do the basic configurations. So the first thing I need to do is to set up the unit. So you can type unit on the command line or just come to this location and then click on drawing unit, utilities, and then drawing utilities, and then go to unit. That is it. You click on this icon, then drawing utilities, then go to units, or you can easily enter units on the command line. Then based on the project we're working on, the length type is going to be in decimal, the precision is to 2 decimal places, and then the unit we are working on is in meters. If you go back to the drawing, you see that we have the distances in meters. So this is one distance between point 1 and point 2. And then you can see this is another distance between point 3 and point 4. This is it. So all our distances are in meters. That is why we have to set the drawing unit to meters. And of course the bearings are in degrees and a minute. As you can see, this is 10 degrees, 00 minute. This is 82 degrees and then 00 minute. So just in case if you are not sure of how we come about selecting the units here. So the units here are based on your project. So if your projects are in a different unit, or your layout plan is in a different unit, then make sure you select the appropriate unit here. So we are working in decimal, precision is 2, the unit, the linear scale unit is in meters. Then of course we are working in the angle type is degree, minutes, seconds, and then the precision is degree and minute. The rotation is clockwise, the direction is north. So these are basic settings that you should be familiar with by now if you have watched my previous videos. So with this done, then the next thing I need to do is to plot this very point. So let me start with the first one. So I will just copy the coordinates and then click on let me open up the point style. So let me start with the point style. So let me now open up the point type. So just type P type and then change the point style. So I'm going to make use of this point style, and then I will set the unit to 5, and then set the unit to absolute unit. So click on OK. Then click on type point and then enter the coordinate of the point. Let's zoom to extent. So this is the first point 1. If I select it and then check the coordinate, you'll see that the coordinates should be the same with what we have here. Then I can do the same thing for point 2. Or actually, let me just label it so that I doesn't mix things up. So I can bring in my text and then just write the text P1. That's the label for point 1. So just P1, and then we are done. I can select it and then increase the font size. That's the text height. Let me set it to 2, or let me set it to 4 so that it will be bold enough. Then I can move it closer to the point. So let's go ahead and plot the second point. So point 2, copy the coordinate, then type in point, then enter the coordinate, and then you have the second point right there. So let me copy the text from P1 to P2. Yeah, somewhere there. And then I can change the label to 2. Then let's plot the third point, P3. Copy the coordinate, point, then paste the coordinate, and then there you have it. Then copy the label, and then change it to 0.3. Then I need to plot the fourth point, which is the last one here. So just copy the coordinate and then type in point, then enter the coordinate. Then let's copy the label. And we can now change it to P4. So we have successfully plotted the 4 points. So we have P1 here, 2, 3, and then P4. So these are the points we are going to use to reference that particular layout raster image. So since we are working with the normal or general or traditional AutoCAD, there is no tool dedicated for georeferencing in the traditional or general AutoCAD. Has it been we are working with AutoCAD Civil 3D or AutoCAD Maps or any GIS software, there are a lot of tools that are dedicated for georeferencing purpose. But here in the traditional AutoCAD, we can only make use of a tool called Align. After all, georeferencing is just about scaling the raster, moving the raster, and also rotating it to fit the expected or given a coordinate. So we can make use of that Align tool to achieve that. So, but honestly, if I need to make a precise georeferencing, I will surely make use of a GIS tool or make use of a AutoCAD Maps or AutoCAD Civil 3D. But since we don't have such software available at the moment, so we are going to make use of the normal AutoCAD tool to reference this particular raster. So what I would like to do now is to bring in the raster image. Or just before then, let me quickly create a layer and then use that layer to import the raster image. So what I will do, I will go to the layer properties. So from the layer property manager, I'm going to create a couple of layers here. Click on new layer, and then I will just call this layer maybe image layout. Yeah, just as an. So this layer is going to hold the raster image or the layout image we are going to import into the AutoCAD environment. So let me create another layer too. So this layer is going to be like the perimeter. So perimeter. So perimeter of the layout. Perimeter layout. Then maybe I could also create another layer for points or whatever, but I don't think it's necessary now. Or let me just create another layer for maybe, let me just say point label. So I'm going to use this layer to hold my point label. So with this, I think we are done for now. If we need an additional layer, we'll surely come back here to create more layers. Click on OK. Then here, currently all my layers are under the default layer. All my drawings are under the default layer, as you can see. So here, I would like to separate them. So let me select the points. So with the points selected, I can now change the layer to perimeter layout. Okay, this is the point label. Okay, we don't even have a layer for the point, so this is not necessary. But let me change the layer for the point labels. So I will just select the point labels and then change the layer to point labels. So now all my labels are under that layer. So let me save my drawing. So here I'll just give it a name like layout plan. So I'll just save it on the desktop and then click on save. So with my drawing set and with my point label change, Then I can now make use of this perimeter layout, and then make sure that it is the current layer, and then I will draw my perimeter. So the first line is from here to here, and then the last one. So the complete perimeter is going to be obtained from the image after the georeferencing. So that is this from this back to point 1. So after georeferencing, I will now digitize the lines accordingly. So what I need to do now is to make the image layer. I'll make the image layer current. Then I need to now import this very image. So to do that, I will go to insert. Then I will go to attach. So there are many ways you can do this, but this is just one of them. I think you can even do something like copy and paste. So I will now select the layout image and then click on open. So if I click on open, I can now click on OK. Then click somewhere and then just make it a little bit bigger so that we can see the points clearly. I think this is okay for now. Then click. So this is the image. So as the image is, it is not georeference. So to actually georeference it, it means we need to make this point 1, the coordinate of the point 1 to be the same as coordinate of the point 1 we obtain from site. Then the coordinate of point 2 on the image should correspond to the coordinate we obtain from site. Likewise, similarly for point 3 and 4. So if we're able to achieve that, the image will be georeferenced, which means the image is now transformed into the real world coordinate system. The pixel coordinates on the image are now the same as the real world coordinates. That is the whole thing about georeferencing. So to achieve that, we use a tool called Align, since we're working with the normal general AutoCAD. So, but definitely if you need a more precise georeferencing, you should definitely consider using a GIS software or AutoCAD Maps or AutoCAD Civil 3D. So for now, since we don't have access to those software, let's make use of the one we have. So just type align. So when you type align, hit enter. Then you need to select the image, which is the object. Then hit enter. Then now you need to click on the source point. So the first source point is point 1 on the image. So click, zoom closely, and then click on point 1 on the image. Then click on the corresponding point 1, which is the destination point that we plotted previously. So we want the coordinate of that point 1 on the image to correspond to the coordinate we plotted, which is the coordinate we obtained from the site. So you do the same thing for point 2. So zoom closely to point 2, click, then go back and click on the corresponding point 2 we plotted earlier. So with these two, you can hit enter to continue, and then select yes, scale object based on alignment point U. Select yes, and then as you can see, the image is moved to that location. So here you can right click on the image, select it, and then right click, and then go to draw order, and then send to back. So when you send it to the back, you should see that we have our points. This is point 1. I'm not sure you can see it, but let me turn off the layer and then change the color. So I'm going to off the layer for the image layout, and then change the color of this. I think let me change the color to red. Let me do it from the properties. So the perimeter, I'm going to change the color of the perimeter to this red, and then let's hope that will be visible on the image. So yeah, I think this is better. So as you can see, point 1 and point 2 are visible. I think I will also do the same thing for the point label. So go back to the layout manager. Then the point label, I also change it to red. Yeah. So we can now see the points. So this is point 1, and then you can see that the image, the lines on the image are aligned with the lines we plotted. So, but if you look at this, this is not aligning properly. So we need to further do the georeferencing using the align tool, so that to further enhance the accuracy of the georeferencing. So I will use point 3 and 4 this time around for the georeferencing. So what I will do is simply go here. I will click on the command line and then type align. Hit enter. Then select the object, which is the raster image. Then hit enter. Then click on the source point, which is point 3 here. Then the destination is the point 3, the coordinate of point 3 we want to align it to. So click, then go to point 4. This is point 4 on the image, the source, and then this is the destination. So when you are done with these two, you click on OK, then click on yes. So as you can see, the raster has been further enhanced, and then as you can see that this part is also aligning now. So with this, let me zoom to extend. So with this, we have georeference the raster, and then we can now carry out the next tasks we have in this video. So I think the next task we need to perform is to determine the size of this irrigation farm. So I think what I will do is to actually create a layer for this irrigation farm. So I'll create a layer, and then I'll call it irrigation farm, just like that. And then I'll make it current and close the layer manager. Then I think I need to change the color a little bit. Let me change the color to something like this greenish color. And then let me change the line width. Let it be a little bit bolder, maybe 0.35 mm. I think with that, I can now digitize this very part. So I will digitize it like this. Just trace the feature correctly. I think let me redo it. So I will delete and then make sure that the line width is showing, and pick my line or polyline, then zoom in closely, click here and click here. The next is here, the next is here, the next point should be here, then the next one is straight down here, then the next one is closing back to the starting point. I noticed an extra line here, so I'm going to remove it. So just select it and then click on erase. Yeah, so this is our irrigation farm. So we need to find the area of this irrigation farm and then split it into 3 equal areas. So since I've digitized it, I can now off my image layer so that I can see what I have there clearly. With this area being digitized, I can now find the area. So to calculate the area, I just need to go back to this tool and then pick my area tool. And then I need to specify the object, or I can actually click around, or I can use object, but let me just click around. I think that will be easier for me, since the area is just made up of lines. So I'll just click around the area, since it's a relatively small area, so I can quickly do that. So just click around, and then when you are done, you just hit the enter button, and then here we have the area in square meters. So the area is given by this value in square meters. So I can copy it to my notepad, and then I can type in area of the irrigation farm is 1457.51 square meter. Square meters. The equivalent in hectares will be dividing this by 10,000, and that should be 0. 0 what? It should be less than a hectare, I think. It should be less than a hectare. Or divided by 10,000, 1, 2, 3, 4. Okay, this should be about 1.4 hectares. If you are not sure, you can make use of your calculator. So if I type in quick calculator, so if I start it, so the value here is 1457.51. I type in the value, then divide should be this 10,000. 1, 2, 3, 4. The result should be 1.42 approximately. So in hectares, the result is 1.42 hectares. So we have successfully completed the first task, which is to calculate the area of this irrigation farm. So we successfully georeferenced the area, the raster, and then now we have digitized the irrigation farm, and now we have calculated the area. So the next thing we need to do is to subdivide this area into 3 equal parts. So our client wants us to subdivide this irrigation farm into 3 equal parts, because it's going to be farmed or used by 3 different farmers. So to do that, we need to make use of a tool provided by. So we need to make use of a tool provided by CAD Studio. Let me open up the web address. So the split area is a tool provided by CAD Studio, and it's free to download and then to use. So it's actually a Lisp program that was written by this company. So if you check my previous videos, you get more detail about this. So that's the tool we're going to use to split up this area into 3 equal parts. So to load the Lisp program, you need to go to the Manage menu and then click on Load Application. Or from the command line, you can just type in app load, and then to bring up the load and unload application dialog box. So here you can navigate to wherever you have saved the split area Lisp program. So just select it and then click on load. So when you have this option, you have the option of always load it when the application loads, or just load once. So here I'm just going to load it once, and then you can see the message here that the split area successfully loaded. So I click on close. So now that we have loaded the split area program, we can now use it to split the area of this irrigation farm. So to do that, we need to type in something like a split area, but before then we need to make sure that this is a closed figure. As you can see, the object is not, this shape is not actually closed, because we didn't make use of polyline. So, but it is easy to convert this to a closed shape. So if I select a part, you can see that they are not they are separated, so they need to be joined together. So I need to convert this into a closed object. So I can make use of either a polyline or use the boundary creation tool. So just type in BO on the command line, and then the object type is set it to polyline. Then click on object, then click inside the boundary you want to convert into a closed object. So press enter, and then now you can see that the object is now a closed figure. So the each line is joined to the next line to make it a closed figure. So I can now type in split area on the command line. So if you type in split area and then you got an error, then it means you do not load the split area program provided by the CAD Studio company I just showed you. So after typing it, then you need to select the object. So when you select the object, the next instruction is to split by number of division or number of arcage. So here I'm going to use the number of division to split this particular area. So number of division is going to be 3. So I'm splitting this area into 3. So I'll type in 3. Then the division line convergence, I will use the default one, which is the direction. Then draw full boundary or multiple subdivision. So I'm going to use full boundary. So I will just use the default option. Then pick initial position to the division line. So I'm splitting this area horizontally. So the first area, then the second area, then the third one. So I will need to have my subdivision line crossing the area in a vertical direction. So I need to click here and then click somewhere here, since I'm dividing the area horizontally. So this is my subdivision line. Then the next, I need to pick the first target. So the first target inside the lot or inside the irrigation farm is going to be on this in this direction. Then the next target is going to be in this part. So I'm going to click far away from the subdivision line. So this part. So now the program will do its calculation and then split the area into 3. So as you can see, the area has been split into 3, where this first part is 1 and then this second part is 2. So we need to further subdivide this part into 2, so that we'll have the first part, second part, and then the third part. So repeat the split area, then select the side you want to split. So this time around we want to split this side into 2. So we're going to split it by number, and then the number is 2. Then the direction, we're going to use direction line convergence for the split, and then we're going to use full boundary to specify my direction of subdivision. So you're going to split this area into 2 vertically like that, the way the line is represented. Then I need to click inside the first part. Then I need to click inside the second part far away from the subdivision line. Then the program will now do the calculation and then split the area into 2. So that makes it 3 in total. So now we now have the area split into 3. This is the first part, second part, and then this is the third part. So this is actually the final exercise we need to perform in this video, and then you can always verify the sizes of the area to be sure that the split was done correctly. So I think we can quickly do that. Or let me first of all label the points, the parts. So let me copy this text here, and then I will just change it. Maybe let me just call it area. Let me just call it IRR for irrigation farm, irrigation part 1. Let me increase the font size. Let me take it to maybe 8. I think 8 is too wide. Let me take it to 6. Yeah. Let me increase this. So this irrigation part 1, then irrigation area part 2, and then irrigation area part 3. Let me just do it this way. This should be 2, and then this should be irrigation area part 3. So let's confirm the areas, the sizes of the areas, to be sure that our split was done perfectly. So I will go to my command tool, my utilities, and then pick area. So this time around, I want to calculate the area based on object. So I will just click on the object. So this is the first part. This is the first irrigation part. I will click on it, and then it gives me this area. So the area is in square meter. So the first part is 4791.18. So let me copy it and then keep it here. So irrigation area part 1. The size is this in square meters. Make this capital M. So let me do the same thing for parts 2 and 3, so that we can compare the sizes to be sure of what we just did. So let me go back to AutoCAD and then repeat my area calculation. Go back, pick the area tool. Then I will split it. I will calculate the area based on the object, and this is the object I want. So the area here is that. I'll copy it to the notepad. Then I need to repeat the same thing for the third. Pick my area measuring tool. Let's do it by object, and then this is the area I want to calculate, and then this is the value we have. So copy it to the notepad. So as you can see, we have approximately the same areas for all the 3 parts. So the first irrigation farm is this value, the second one is that, and then the third one is that. So that is how to perform the area splitting in AutoCAD. So far so good. We have been able to georeference this raster layer. After we georeference it, we digitize features of interest, which is this irrigation area, and then we splitted the irrigation area into 3 different parts. And now we have 3 different boundaries for this irrigation farm. So we can easily get the coordinate of each of these parts, and then go to site and then set them out. So in the next video, we are going to continue with digitizing some other parts of this layout. And as I've mentioned, we are going to reproduce this layout, make some corrections to the mistakes that were made on the layout, and then add some additional features and digitize the entire layout block. So I will see you in the next one. Till then, have a nice day. Bye bye.